don't assume my numbers are right. I'm just using it as an example. So let's say 1, 2, 3, 4, 5 seconds. If you use different times, that's totally fine. Okay? I'm just using examples. Okay? And again, I'm making up these numbers, so don't assume my numbers are right. Okay, so let's say for trial 1, I got 0.97, 0.92, 1.03. Okay, so then I would average them. Make sure when you're averaging, you're adding across the row. Don't add your time, just add your distances. So here we got 0.97, 0.92, 1.03. And then divide that number by 3. So my average was 0.973. And you're going to do that for all your times. So you need to get an average for all of your different times. And then again, this is the average distance traveled. So I got 0.973. Again, I'm going to make these up, so don't assume they're right. 1.93, 2.89, 3.84, 4.80. Okay. Don't assume my numbers are right. I'm just getting numbers for you guys to do. So what you want to do if you're doing it on the computer is you want to go to desmos.com/calculator. When you do, it'll give you this. All right, first thing you want to do is you want to click the plus sign and click table. And then you're going to enter in the numbers. So you're going to start by entering in your times. So 1, 2, 3, 4, 5. Use whatever times you use. If you didn't use mine, that's fine. Just whatever you used. And then in the Y, you're going to enter your averages. So I'm going to put in mine. Okay? Once you've done that, click the plus again, click table again, and now do the same thing, but do it for your little card numbers. So, because we're doing them on the same graph, you have to make sure that your units are the same. Make sure these are in seconds, make sure these are in seconds, make sure these are in meters or centimeters. I don't care what unit, but it has to be meters or centimeters. Or I guess some of you may have done inches. I suppose that's fine. But make sure both of these are in the same unit. Okay? So go ahead and work on putting those in. If you're doing it by hand, make sure you got all your averages. If you're doing it by hand, here's what you need to be working on. Sorry, different class. But I didn't want to forget. So, if you're doing it by hand, you should be doing it this way. So, you'll label what it is. So, this is time versus distance traveled. Okay. If you're doing it by hand, you need to set up your own scale. It won't do it automatically for you. So to set up your own scale, what you do is you look at your chart and you say, okay, my largest time is 5, my smallest time is 1. So it makes sense to count up on my scale by ones. Your independent variable goes in the x-axis, so time goes here on the bottom. But I need 5 to end up over here. 5 can't be over here. 5 needs to end up over here. So I need to skip enough spots so that 5 is way over here. So I'm going to start at 0. And I'm going to go up to 5. So I'm going to say 0, 1, 2, 3, 4, 5. Here's 1 second. 1, 2, 3, 4, 5. 2 seconds. 1, 2, 3, 4, 5. 3 seconds. 1, 2, 3, 4, 5. 4 seconds. 1, 2, 3, 4, 5. 5 seconds. 1, 2, 3, 4, 5. 6 seconds. There you go. That's pretty good. And I need to do the same thing with the y-axis. So my largest number is 4.8 meters. So that's 5. So I need to count up to 5 on the y-axis. Again, count up by a set number. I'm going to count up by 0.5 this time. Okay? And I still want 5 to end up near the top. So here we go. 1, 2, 3. I'm going to go ahead and I'm going to try going up by 5 again. 1, 2, 3. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and now I'm ready to start putting my points on here. So I would go 1 second, 0.93. So I would go 1 second, 0.93 is, or 0.97 is like almost to 1, but not quite to 1. So something like that. Okay, go ahead and do that. Go ahead and, if you're doing it by hand, go ahead and make your scales. Don't assume your scales are the same as mine. Make your scales, plot your points. If you're doing it on Desmos, enter both your charts and get the dots. If the dots don't show up, you may have to adjust the screen a little bit. Zoom in and zoom out, move it around a little bit. Try to get it to take up most of the page if you can. Okay, I'm going to come around and see what questions you all have. For those of you doing it by hand on here, you're going to find your points and put them on here. So mine looks something like this. Okay. All right, so I'm putting my points on here. And then if you're doing it by hand, you're going to need a ruler. Now, I have a whole tray of them up here. And what you're going to do with your ruler is you're going to make a fit line that goes through the points as best you can. It's not going to hit them all. You just want to follow the pattern as best you can. So something like this. And there's the line. Now, on Desmos, you'll notice, good job, me. You'll notice that I have the equation. So here's y equals m. Here's the value for m. X plus b, and here's the value for b. Okay? If you're doing it on paper, you're going to have to come up with that equation on your own by figuring out the y-intercept and figuring out the x-intercept. So the equation you're trying to do is this, y equals mx plus b. To find m, you're going to use the point-slope equation. Slope is equal to y2 minus x2, or sorry, minus y1 over x2 minus x1. What I mean by that is you need to find two spots on the graph where the lines intersect the grid lines. So I'm looking for where my line intersects the grid points. There we go. Okay? So then I figure out, okay, what's the y for this? What's the x for this? So this looks like, for me, this would be 2.2 seconds, and this would be 2.1 meters. And then do the same thing for this one, and then subtract them. So right now, work on finding the slope of the line and drawing the fit lines as well. I'll come around and see how y'all are doing on that. Okay, so if I'm doing my little car, it's going to be something kind of like this. Now, again, don't assume your numbers are the same as mine. But notice that, again, here's mine. It's kind of a curve. So I'm going to kind of draw a curve that kind of fits it as best it can. All right. I'm going to make another loop around. See how we're doing here. How we doing? How we doing? Did you get the curvy thing? Well, who's the curvy thing? Yeah, so go back to your thing and then change it to that other thing. So, what is the line telling me about the car? What's the slope telling me? Why did we need to do a fit line? Why didn't we just leave the points and call it a day? How accurate do you think you were? And how precise do you think you were? This we haven't talked about yet, so do your best and tell me, do you think you're accurate or not? If you think you are, why? If you think you're not, why not? And then, do your numbers make sense? Yes or no? And tell me why. When I say precision and accuracy, remember, precision is how repeatable are your numbers. What I mean by that is, do your trials match up pretty good? And by accurate, I mean, how close do you think you're getting to what you should be getting? Okay? Your homework is just to finish that. Your homework is finish the lab. You don't have to do anything else other than that. Finish the lab. I'll have a submission available for you next time, and you can turn it in there. Any questions?